Okay, so this is a more standard pulley question as we've got two masses here, but there's quite a lot of things it's looking for in terms of speed and time. So it's quite a long example, this one. It doesn't just look at the forces. So we've got a light, inaccessible string passing over a smooth pulley. So it seems to suggest the pulley is like this, with the object hanging down from it. And it tells you here, if you read it, the mass of P is 2.3 kilograms. I could put that in there, but I'm just going to put the weight instead as 2.3 G, not grams, but force of gravity. And that's P. And then it says the mass of Q, 3.1. So again, the mass would be 3.1 kilograms, but the weight is 3.1 G. And it says here, and just be careful when you're reading it, because it then swaps the order. So it says Q is initially held 80 centimeters above the floor. So that's the first one it talks about is actually the second labeled diagram. 80 centimeters is probably no use to me. So what I really want to be doing is put in 0.8 meters. So you can understand meters, seconds, kilograms. Those are the kind of standard units. And then P is 0.9 meters below the pulley. Okay, so there's no information of whether they are same distance above the ground or whether they're level, but that's the only information we know about them in terms of their location. And it says the particles are released from rest and the system moves freely under gravity. So this object and this object are both going to have some sort of tension force on them. Imagine it doesn't really matter if they're at the same height to begin with. What matters is once they are released from rest effectively, then the forces take hold. And what will happen is that this is the heavier object, this will move down, and this will move up, so the overall direction being positive is kind of up and around the corner this way. So we want a speed, okay, and obviously that is suvat, but at the moment you're probably only going to have, when Q hits the ground, you're going to know how far it's going to travel to hit the ground. Let me just write a better Q here, looks more like a fish or an alpha. You know that it starts from rest, so that's 0, but we don't know anything else, so we're going to have to calculate the acceleration in order to do that, and that's where we need the F equals ma. So we need two separate F equals ma's. We need one for the object of P, okay, and that is going to be moving upwards, and we need one for the object of Q, and that's going to be moving downwards. Now, because they're moving in different directions, we have to have the two separate F equals ma. When we have something like a car and caravan, car and trailer, because they're both going in the same direction, we can go straight into a whole system F equals ma. And you know, we can also have the separate particles. With pulleys questions in maths, if you don't write the two separate F equals ma, you are not going to get, even if you get the right answers, you're not going to get your full mark. You have to have separate because they go in different directions. So for P, this object here on the left, effectively you've got these two forces acting directly on it, and then for Q we've got these two forces acting directly on it. No kind of area systems or anything like that that's mentioned. So for P we've got tension minus 2.3 G equals, and the mass is 2.3, so 2.3 A. This object is moving downwards, so it's going to be the opposite. It's going to be 3.1 G take away the tension, and that's equal to 3.1A. And what you'll always notice is this pattern with Pulleys equations, one with a T minus something, generally minus something, and something with a minus T. So positive T, negative T, you will always see that pattern. And the easiest way to deal with those two equations, although not the only way, let's call this equation 1 maybe, call this equation 2, is to add them together. Okay, and if you should notice something in terms of patterns and stuff when you do that. So you've got to be careful you can add them together. So you've got to realise that that's got a negative, so it's not going to be 5.4 G. And if you get A as 9.8, you might notice that you've done something wrong, i.e. you should get that effectively will end up being taken away because it's negative. So it's going to be 0.8 G equals 5.4A. So 5.4 G equals 5.4A, something's gone wrong. And then if you rearrange, A will equal, I've done that in my calculator, I've got 1.45. I'm going to leave it as 1.452 because it doesn't ask me to calculate this, which means it's not a final answer. It actually doesn't need the tension. You could just sub back it if you need the tension, and probably into the first one's easier. But I don't actually need the acceleration for an answer. I need it for doing part A in general. So I now need the speed when Q hits the ground, so that's where the suvat kicks in. So we're looking at object Q. To hit the ground, it's got to go 0.8 meters. Again, that's got to be meters. We know it says it's released from rest. That's 0. We want its speed. So that's kind of related to the velocity. And we know the acceleration is 1.452. Okay. And the time at this stage, we don't know, don't need, although it does say here, find the time it takes P to reach the pulley once it's released. So we might actually need something to do with that bit later for part B. Just in terms of part A for now though, we're going without T. So that is the equation V squared equals U squared plus 2AS. Didn't have space to put that one on the slide. So it's V squared equals, well, 0 plus 2 times this 1.452, or the value in your calculator possibly. If you've still got that, it should be easier, so more accurate. So V squared equals, and then V equals, and let's see what we're going to get. So that number times by 2 and times by 0.8 is giving me 2.323. If I square root it, I get 1.524, 1.52 meters per second to the rounding I'm looking for. I think that's right. I'm using my iPhone calculator because my graphical calculator's in my bag somewhere in the other room. And that's what I need for the first bit. Check that in the textbook before I finish this video. And it says here, once Q reaches the ground, P continues to move upwards. So what you've got to understand is, when Q's, so far in the first bit of motion, Q's gone down 0.8 meters, and P has gone up 0.8 meters. And they're doing exactly the same thing, but in the opposite directions. So if this is the speed / velocity when Q hits the ground, instantly before it hits the ground, it will also be the velocity, and well, in fact the speed, because the velocity was supposed to be negative, it will also be the speed that P is travelling when it travels 0.8 meters up. It'll take the same time for both those things to happen because they're attached by that string. They're in kind of synchronicity, if you like. So we can use information from here to help us. So I need two things. I need the time it takes P to go up 0.8 meters / Q down 0.8 meters. I'll find that first. And then I need the time it takes P to go up another 0.1 meters. Okay. So let's do the first bit. So that's this same suvat, but we're looking for the T instead of the V. So I'm not going to use the V. So without V, it's S equals EUT plus a half AT squared. So it is 0.8 equals 0. That's the first bit 0. And then a half of the 1.452 times by T squared. On my calculator. So 1.452 divided by 2, and then I need to do 0.8 divided by that number. So it's hard in my... So I think that's 1.05. Just checking the textbook before I move on to doing that bit. During that time I could have just found a calculator. Oh well. And then the second suvat, I'll go back to my blue pen for no particular reason. So it needs to go, so this one is still, that's one's Q going down, but technically the same as S going up. And then this one here, so we've got S, U, V, A, T, so we know it's got to travel another 0.1 meters. We know at the end of the first 0.8 meters it was going this speed / velocity, so 1.52, it's 524. 1.52 is fine. V, I think we're not going to be interested. It's not like it stops at the top, it's just if it can hit the pulley. The acceleration, so that's when you have to think a little bit about. So once once the first one's hit the ground, the string's effectively got no tension in it, so the acceleration, because it's just up and down, is just negative 9.8. So it's on the way up. String's doing nothing, so it's just gravity fighting against it, and t is what we're looking for. So no v means again s equals ut plus a half at squared. So this time 0.1 equals 1.52t minus 4.9t squared. I'll rearrange that appropriately. So 4.9t squared minus 1.52t plus 0.1 equals 0. And that's going to give me t equals either 0.0947 or t equals 0.216. Now obviously what you've got to understand is in the context, this Suvat equation doesn't know that we're talking about it hitting the pulley. Okay, so as far as it understands it, what's going to be happening with P is moving up and then stopping and come back down, so we want the smaller of the two times. Okay, and the second one would be theoretically coming back down if it didn't hit the pulley. So the time is going to be 1.05 plus this 0.0947, which overall, if we add them together, is going to give us 1.14 to 3 sig figs, 1.14 seconds. Okay, so this one testing your F equals ma to begin with, and then your understanding of the Suvat, including the idea now with pulleys that these two are doing the opposite and equal kind of things, and obviously when the one hits the ground, the tension's gone in the string, and you'll be just under gravity. If, for example, it was an even more complicated question, it might talk about this one going down, this one coming up, and then them starting again. So like this second time, if the pulley's not there, hasn't reached that pulley, this could go up and then come back down, and then if it comes back down to that same 0.1, it would be kind of lifting this one off the ground again, so that maybe start moving, but it's definitely a more complicated idea.